Okay, we're on section 1, 2. I got a big old ruler right here because that's what we're going to do. We're going to measure some stuff. And in fact, everybody listening, right? Okay. In fact, we call this lesson linear, what do they call this? Measure. Okay. Almost forgot myself. All right, we call it linear measure. Because we're measuring something. And we're measuring, what word is in this word linear? Line. All right, so we're measuring lines is exactly what we're going to do. So let's put a line up here, and let's measure it and figure out how to do that. Because I'm going to give you a worksheet, and they actually ask you to measure lines. They'll give you a length of a line, and they'll say measure it. So this ruler right here, it's got two different types of measurements. You can measure it in centimeters, or you can measure it in inches. Let's measure it in centimeters first, and then we'll measure it in inches. Okay, so what we're going to do is take this up here like this. Now, where do we put it? Do we put the edge of the ruler right against the line like that? Let me blow this up a little bit so we get a closer view. All right. So we don't put it there. Where do we start it? At the 0. Okay, so let me just about right there. That's pretty close, right? So we want to measure that length of the line. Now, I think I blew it up too much, but that's okay. It starts at 0. Scooch it over. And look where it ends up. Now this is 11 right here. This is 1, 2, 3, 4. Does it hit the 6?
Yeah.
Yeah, we'll say 6. Okay. So so what do we say? 11 what? Point what? 6. Now it's in centimeters because look at this 11. It's broken up into how many different parts? From here to here, that would be 1 centimeter. How many parts is it broken up into?
10.
It's in 10, okay? So that's centimeters. So it's 11.6 what? Centimeters. So from 11 to 12 is 1 centimeter. What is it, these little tiny ones? That's a millimeter, right? Because there's 10 millimeters in 1 centimeter. So if you wanted to, you could write it in millimeters as well, couldn't you? What would it be in millimeters? I want a number, not a lot. 1,000 millimeters? That's right. You just have to move it 1 decimal place, okay? Because there's 10 of these millimeters in 1 centimeter. So basically, you just multiply that by 10. And it's easy to multiply by 10. You just take your decimal and you move it to the right. Georgie, you getting all this? Get your head up, please. If I have to tell you again, I'll have to write you up. So it's 116 millimeters. You could do it either way, all right? Now, read the instructions. If the instructions say, find out how many centimeters or whatever, if it just says measure it, you could say 116 millimeters, or you could say 11.6 centimeters. It doesn't make any difference. Everybody with me on that? And you might have a question like that on a quiz and a worksheet and that kind of stuff, right? So make sure you know how to do that. Let's do this in inches this time. Let's bring this line down here like this, okay? Let's measure it in inches. So let's blow it up a little bit. Maybe not so much. That's good enough. So we move this around. Let's get it a little closer. How about right? That's a good spot to put it, isn't it? Starts right here at 0 and it goes. Now let's think about the inches though. Inches are a little bit tougher than the centimeters, because the centimeters, everything's by 10, so it's like point something, right? Just count how many lines over. It's either 0.1, 0.2, 0.3, 0.4. On inches is a little tougher, so let's figure out what our dimensions are. Like, let's start at 0 to 1. So this is 1 full inch going to 0 to 1. What does this line right here represent? The half, right? So that would be 1/2 of an inch. And then if you take half of that, that would be this line right here, and that's how much? Half of a half is what? A quarter, right? 1/4. Okay, so it'd be 1/4 of an inch. What about this line right here? That would be half of a quarter. What's half of a quarter? It's an eighth. So this would be 1/8 of an inch. Everybody see that? So each one of these lines, it's not 0.1, 0.2, 0.3 like it was with centimeters. It's now what? It's 0. Then what's this first one? An eighth. This is 2/8, which is a quarter. This is 3/8. It doesn't reduce, so we just call it 3/8. This is 4/8, which reduces to a half. This is, talk to me, 5/8. This is 6/8 or 3/4, right? 3/4. This is 7/8, and this is 8/8 are just 1. Right, 8 over 8 is 1. Everybody follow me on that? All right, so if we're going to measure this, each one of these little ones is 1/8. Now, sometimes it might be right in between. If it is right in between, just pick one that it's closest to. All right, that's good enough for me. So what do we got? We've got 4, right? And then what's that? That's 1/8, 2/8, 3/8, 4/8. But what's 4/8? It's 1/2, isn't it? Okay, so I'd say it's pretty close to this. So I'd say it's approximately 4 what? And a half. Okay, what if it went to the, I'll tell you what, let's extend this out just a little bit. Like right there. What if it hit there? What would it be there? 4 and 1/8? 5/8. Okay, I'm sorry. I thought you said 1. Right, 4 and 5/8. Because this is, watch again, 1/8, 2/8, 3/8, 4/8, and what? 5/8. So this one, oh, that's a little thick. Let's go back to make it a little thinner. So this would be what? 4 and 5/8. What? Inches. Okay, that's in inches. Are we okay with that? You probably did this when you were a kid. You probably, your teacher gave you stuff you had to measure. It gave you a ruler and you had to measure it out and all that kind of thing, right? But I don't think we need to do that here. I think this was good enough. All right, so that's the kind of stuff they're going to ask you to do. So what did we just do? We are measuring lines. That's this whole deal. All right. So let's talk about lines. Since we talked about lines before, what do lines do? They got arrows on the end. What do those arrows represent on lines? That they keep on going, right? So we're just backtracking a little bit. We'll call this A and we'll call this B. So what would I call this situation right here? Line AB, right? So I put a little line symbol over top of it. That represents it's a line. Again, what does a line do? It keeps on doing what? Keeps going both directions, right, Freddie? Okay, get your head up, please. That's your warning. I shouldn't even have to give you a warning. That's it. No more warnings, okay? All right, I've given everybody fair warning. If your head's on the desk, all right, that means it's on the desk. I want it up. That's right. That's sitting up, okay? That's it. That's all the warnings. Next time, I'm writing you down for an SLD if your head's on the desk. Everybody got that? Okay. So I've got line AB, or I could call it, what else? Line BA, right? But again, what do we have on top of here? We got a line symbol, right? What if we did this? Now watch. What if I, let's do another one. We'll still use AB. What if I had a little dot right there, though? Not an arrow, right? Does that mean, does it keep on going? No, it doesn't. Not without an arrow. So if I call this AB right here, does it keep on going in that direction? No, what's it do? It stops, doesn't it? Starts and it stops. Right? So we don't call this a line. This right here, we call it a line. Just, that's it. No other words, just line. That automatically means it keeps going in both directions. This thing right here is not a line, because a line has to keep going in both directions. But we call this a line segment. Are you writing this down? Everybody should be writing. As soon as I wrote that down, I should have seen your hands moving with a pencil in your hand or a pen in your hand. Okay? Write it down. This is a line segment. A line segment starts and it stops. We can actually measure a line segment. Can we measure a line? Could I take the ruler and measure this line right here? Why not? Taz, why? Because it keeps on going. There's no way I have a ruler big enough to measure a line. So I cannot measure a line. It's impossible because it keeps on going forever, and there's no way I could get a ruler that big to measure something that keeps on going forever. But I can measure what? A line segment. I can measure a line segment because it has a beginning and it has an end. All right, so I can measure something like that as long as the ruler that I have is long enough, right? Even if the ruler is not long enough. Let's say I wanted to measure the height of this ceiling from the floor to the ceiling. Look at my meter stick. It won't go all the way to the ceiling, will it? So what would I do if I was to measure how tall it was? Take what?
Tape measure.
Okay, tape measure, but let's say the only thing I had was a meter stick.
Reach.
What's that? Reach up. What would I do? Come on, think about it.
Jump. Stand on top of something.
John, what are you saying?
Stand on another plane.
Roll it over. Yeah, it's a good way to say it. I like that. Roll it over. That's right. Because look, if I wanted to measure from this wall over here, okay, to that wall over there, this obviously is not long enough to measure that in one shot. So what do? I put it here, and then I what?
Oh.
Flip it over, roll it over, right? So that would be 1 meter, that would be 2, that would be 3, that would be 4. You follow me? Okay. So yeah, I could measure something that's longer than what the ruler that I have. Okay? Just roll it over, just flip it over, and just start counting all the meters. Okay? So, but I couldn't measure something that goes on forever. All right? I could never do it. This is the line segment. Let me show you the way that we write line segment. A line, if I saw that, automatically I know it's a line and it keeps on going in both directions. A line segment would be written like this. You still put the A and the B next to each other, but then you put a little line without an arrow. Okay? You don't put dots on it. A lot of people put dots. You don't. But you just put a little line with no arrow over top of it. That means it starts and it stops. And these things right here are called your end points. End points. Write it down. So that's an end point, and that's an end point. Some people might think, well, that would be a beginning point because it starts at A. Well, you don't know it started at A. It could start at B, right? But the points on the end are the end points. Makes sense, right? John? Okay, if there's a point in between, good question. You'd have to put AB if you're talking about the whole thing. If you're talking about from here to here, that's AB. You couldn't call it AC. Now, over here, you could have called it line AC, couldn't you? Because it goes through C and it keeps on going, and eventually it would go through B. On this one, I couldn't call that whole line segment, I couldn't call it AC. I'd have to call it AB, all right? Or BA. Doesn't make any difference. Now, AC is a line segment, though. From where? It's got to go from A to where? To C. So this little tiny one would be line segment AC. This middle one would be line what? CB, right? But the big one would be AB. Does it make sense? All right. What if we were going to measure it, though? Watch this. What if I put like a 2 right here? If I put a 2 here, and I got a dot here and here, what do you think that tells me about the length of AC? It's 2. That's right. So if I put a 2 here, that doesn't mean it's the length of the whole entire line segment. It just goes from dot to dot. So that's a 2. What if I said that was 5? What would that be measuring? From C to B. Line segment CB. Exactly right. Okay. What would the whole thing be from A to B if this was 2 and this was 5? 7. Right. Just add them up. Make sense? Now let me show you another symbol. It's actually a symbol that doesn't have a symbol. You're like, what in the world is he talking about? So watch. If I talked about the length, listen to me. If I talked about the length of AC, of line segment AC, we actually have a symbol for that. Instead of writing the word length of, what we do is this. We just put AC and then nothing over top of it. We just put AC right next to each other and then nothing over top of it. What does that mean? It means what? The length of line segment AC. So you might have a problem that says this. It might say find AC, and that's it. That's all they say. They say find AC. Well, what does that mean? It means find the what of AC? The length of AC. All right, that's what we're doing. So you come up here. Here's your situation. Here's your picture. And if this is your question, find AC, what would your answer for that be? It would just be 2. That's right. So if you wanted, you could just say AC equals 2. This means the length of AC equals 2. What about CB? If I just said find CB, what would you tell me? You'd say it's 5 because it's the length of line segment CB. Does that make any sense? So I would say 5. What if I asked you AB? Then you got to do a little work, right? Not much. It's very, very little work, but you still got to think a little bit. If I wanted to find the whole thing, AB, I take this little line segment, take the medium line segment, and do what to get the whole thing? I add them up. So 2 plus 5, obviously, is 7. So that's how you would write this. So this is the kind of questions they're going to say. So you need to understand what they are talking about, what they mean when they ask you these questions. If it just says find AC, you know, somebody says, oh, what does that mean, find AC? It means find the what? The length of it, okay? The length or the distance between those 2 points, okay? The length of AC, that's what they're talking about, all right? That's one that people forget about a lot, but this means the length of AC means, I'll put a little arrow there, instead of writing length of, all we got to do is write AC with no little line over top of it, and that means you're finding how long that little segment is. Make sense? Sometimes they'll get a little bit more complicated. Sometimes this is not much more complicated, but it's a little bit. We're going little baby steps here. Oops, didn't want to do that. What if I did this? Let's put a dot here, dot here. Let's put another dot right here. And let's say I said that this was 3. Now watch, and sometimes they do this. They'll put a little thing like this. You guys watching? Sometimes they might do this. Alright, and we'll label these points. We'll call it ABC again. Alright. And they might say find, or sometimes they'll do this. Watch. Sometimes they'll put a little X right there, and they'll say find X. Or they might say find BC. Alright, it just depends on how they write the problem. Georgie, what would you say? 7. How did you get 7 out of that? That's right. It's just 10 minus 3, right? Because look, the whole thing is 10. This little part of it is 3. So what's left over? That's what we're doing. And what do you do in math when you find out what's left over? Usually, you're subtracting, right? That's exactly what we're going to do right here. Take the whole thing, 10, take away 3, and that's what BC is. So it's 10 minus 3, which is 7. So that's BC. Or they might put a little arrow, or not an arrow, but a letter right there. And so you want to find what X is. Is that making sense? Now that was pretty simple, right? It wasn't real difficult. Sometimes they get a little bit more difficult. Sometimes they'll put fractions. All right, so let's do one where they put some fractions in here. And let me find. Give me a second here. I'm not using the book, but I am finding something else. Okay, here's a good one. Everybody writing this stuff down? I hope you are. Okay, write it down. Write it all down. I don't know what's so difficult about just writing down what I write down. You don't even have to think. All you got to do is copy. All right, so write it down.
Did you tell me like this?
I did, to wake you up. It's pretty good. You're sleeping with your head up off the desk, though. I'll give you that much. So look what we have here. We've got 2 and 3/8, and we've got 1 and 1/4. And the question says, it says find the measurement of each segment, and they'll basically say this. They'll say find AD. And there it is. So there's a problem. This is a problem very similar to the kind of stuff you might have to do on your worksheet. So what's the math involved, though? What do we do? Justin, tell me. You add them up. That's right. Because look, this time they give you each individual segment, and what do you want to find? You want to find that whole thing, right? So how do you find the whole thing if you know both the little ones? You add them up. So it's 2 and 3/8. We'll do it like this. You guys probably like writing it like this, right? And then we'll just add them up. Okay. Try not to use a calculator for this. Remember when you were a little kid, you did this stuff. Put a 2 and a 1 here. Common denominator. I got an 8 and 4. What's the common denominator with 8 and 4? It's 8. Okay. So you put an 8 here. Put an 8 here. It's coming back to you. 8 times 1, 3 times 1 is 3. 4 times what? 2. 1 times 2, 2. You add them up, you get 3 and what? 5/8. Okay? So there it is. So that's what AD is equal to. Remember that stuff, don't you? You can do that without a calculator, right? Yeah, you should do that. Now, if you know how to use your calculator with fractions and get it, I'm not going to say that you can't do it that way, but I really want you to know how to add fractions together, and that's why I always do it that way every time. And that's it. That's how you do that kind of stuff. Now, let's get a little bit tougher. Everybody write that down? Everybody got it? Okay. Let's go blue this time. Let me find a good one. All right, so let's write down a oops. Make it a line. Let's do our line again. It's going to be basically the same kind of thing, except the numbers are going to look a little bit different here. We'll put a dot right here, put a dot right here, and we'll label it X, Y, and Z. This is right in the book if you want to look sometime later, but just look up here for right now. Watch this. They say that this is 3A. They say this is 14, Now watch what they do. They put that little line to show you what the whole thing is equal to. Little squiggly lines, but you get the idea. And this is 5a. Now you got to watch. I'm telling you, if you're not paying attention here, you're going to be really lost. I promise you. You won't have a clue what's going on. All right, so make sure that you see what's happening here. Now remember on these, what did we do to these two to get the whole thing? Just tell me. We added, right, okay? And then look at this. Now we did subtract here, but really, what is this and this doing to get 10? It's adding. So I could have done this. I could have made an algebra problem out of it, couldn't I? If I wanted to, right? This segment plus this segment equals the whole thing. And then what would we do? Subtract 3, x is 7. Everybody see that? So really, what did we do? We just took the two segments, added them together, and set them equal to the whole thing. Now keep that in mind. I did that for a reason. Let's go back to that problem down here. Now, what must be true about this xy and this yz? What can we do to this segment and this segment? We can add them together, and what's it going to equal if we add them together? Say it. 5a minus 4. That's right. Okay, so I'm going to take this, 3a, and I'm going to take this, 14. I'm going to add them together. Everybody see that? So I took the little one, I took the middle one, I added them together, and what should it equal? It should equal the whole entire thing. And the whole entire thing is 5a minus 4. So what we did right there is the very first time, the first of hundreds of times we're going to do that this year. We took a geometry principle and we turned it into an algebra problem. Okay? That's exactly what we're going to do really the rest of the year. All right? That same process. So I took my geometry. I knew that this plus this equals the whole thing. I set it equal. Now I can do my algebra. This is why I wanted to teach you that algebra at the beginning of the year, because you're going to use it a lot. So let's do it. I got 3a and 5a on either side. I want them on the same side, don't you? I would subtract a 3. This is how I would do it. I'd put this on the right side. Now, why would I put it on the right side? So you don't get a negative. Exactly right. Okay, so I get a nice positive here. Now, in the same step, I got the a on the right-hand side. Let's get rid of this minus 4. How do I get rid of that? Plus 4. Aren't you glad you learned that in the last chapter? Plus 4 right here. That cancels. That cancels. Let's add up everything else. What's this add up to be? 18. What's this become? 2a. You know the next step, right? Divide by 2. What's a equal to? A is equal to 9. Okay? And this question says, let's see what it says. Yep, it just says, oh, it says find the value of a and xy. So it says find the value of a and xy, the length of xy. When you don't have that little sign over top of it, Justin, you getting this? When you don't have that little sign over top of it, that little line, that means find the length of. Okay, find the length of xy. So we found a, so we got that already. So that's half of our answer. What are we trying to find now? Xy. So xy is from here to here. So what are we really doing? Right. We want to find 3a, don't we? So we just go what? 3 times 9, because a is 9. So we found 9. We just plug it into this. What's that? It's 27. So this length right here is 27. Now, you look at this and say, wait a minute, that's shorter than this, and this is 14. That can't be 27. But they do that to you sometimes. All right? Just because this looks shorter than this doesn't mean that that's the wrong answer. Okay? Sometimes they do that just to kind of trick you a little bit. All right? So don't always believe just because some segment looks bigger or smaller than another one that that's true. All right? So that's the kind of stuff you're going to be doing. Let me do one more thing. Let me give you a word here. What if I had this? Let's go a different color. What if I had this line segment? All right, now watch what I'm going to do. I'm going to copy and I'm going to paste. You ever do that on your computer? Copy and paste. So what's true about the lengths of these two lines? I copied and pasted. They're exactly the same, aren't they? They're exactly the same. So this is what we do. This is, and let's label it, okay? Let's call this, well, they don't have to be parallel. I mean, these probably happen to be parallel, but they don't. Parallel really has nothing to do with what I'm talking about right here. Now watch. The length of AB is equal to what? I copied and pasted, so it's got to be what? Equal to the length of CD. Agreed? Now here's how we show this. We show this in geometry by using a thing they call a tick mark. We just put a little mark here, a little tick mark right there. And if that has one tick mark and that has one tick mark, what does that tell you about those two line segments? That they're exactly the same. Okay? So that little tick mark tells you that those two segments are the same. If I would have just had them up here on the screen and didn't tell you I copied and pasted, you may think they were the same, but could you tell for sure if they were the same? No. But if they put a little tick mark right here, what does that say about those two segments? It means they're the same. Okay? Now let me show you a word. We don't, in geometry, when we talk about line segments, we don't normally say they're equal to each other. We can say the lengths are equal to each other, but what we can do is we can say that line segment AB and line segment CD, don't pack up yet, we're not ready, are not equal but congruent. Let me write that word down. That's all right. Congruent. That's a very important word. We'll probably use that word more than anything all throughout geometry. Look at the symbol. Everybody looking? We're not packing up. Watch here. There's an equal sign with what? Little squiggle thing on top, right? That sign right there means what? It means congruent. Just wait till I'm done. All right? So that means congruent. So that's the stuff that you need to know. I'm going to give you a worksheet, and that's due on Monday.